So, like I said earlier, that I'm finding that there's probably different ways or different routes of how to go around this. Like if I did it like a few times, like I have it worked out in here, and I worked it out on a different page. I get the same answer, and you got the same answer. So, you know that it could be worked out in different ways, right?
It's like proving identities almost.
Yeah, it's like proving an identity. It's like, okay, now let's get to letter G, and then, yeah, we got letter G and letter H to work on. Now, this one, I can see that there's a base E in here. So, I think the most, like, a better way of doing that is to just use natural log ln, right? Okay, so we're gonna go natural log of 3 negative to the exponent negative 3x plus 1 equals to natural log of e to the negative x. Okay. Put this at the front, so negative 3x plus 1 times natural log of 3 equals to negative x. That's going to be natural log of e. Okay. Now, this part in here, this is a base e, right? E to what exponent will get e? That's just 1, right? E to what exponent will get e? It's 1. So it's going to be negative x, negative 3x, plus, forgot the other one. This one here, this is not 1 because they operate with the same different bases. Base E, this is number 3. So what we need to do is we need to multiply that in, so that becomes negative 3x natural log of 3 plus natural log of 3. Okay, so we got some x values, x is on each side. We're going to bring this to the other side. That becomes negative 3x natural log of 3 plus x equals to, we can bring this to the other side, negative natural log of 3. Okay. Now, how can we isolate these two? We can't even combine these two because they're not even the same term. The way to extract the x is by factoring. So I'm going to go this way. It becomes x times negative 3 natural log of 3 plus 1, thank you, equals to negative natural log of 3. Okay, so from here we can just say x is equals to negative natural log of 3, ln of 3. Instead of saying natural log, it's ln. Negative 3 ln 3 plus 1. And that one we can figure that out and see what number we're going to get. Well, my calculator doesn't have just an E button. So if you have this calculator, I don't know, I didn't see just the E button in here. The only thing that I can see, as far as I can see here, is this E to the X. So I have to type in E to the 1 to just have the E, unless you can see it, see what you're seeing. But I think some calculators have just an E button, right? Everybody have an E button?
Nope, I just
I have an
have
ad.
the E to the X, but
Just
also
E.
I do have an L.
Yeah.
But do you have E to the X?
You do a blank.
E to the blank, or just an E? Okay, then for me to do that, I just have to go E to the 1, right? Because E to the 1 is E.
Whenever I just type that in, it just gives me one.
Oh, it's,
When I hit second function and do that, it just gives me one.
yeah.
It's easy.
E, sorry. We don't need an E. It's, yeah, we don't need E. What am I talking about? But I don't have E anyway, so it's okay. Let's see. Negative, let's try that again. Negative natural log of 3 divided by negative 3 do you get 0.479?
Yes.
0.479? 0.338. Okay. 0.479. Did you maybe type the negative? Okay. Did you? We need to put a bracket around here. Let's see. Oh no, yeah, minus natural log of 3. Yeah.
I have this. Does that mean I can use any base?
Oh, yeah, I don't know. Let's see. Did you get it? Yeah? Yeah? No?
This calculator is pretty damn dusty. I just found out I have a log button. Or I can have any base. I wonder if I can divide by any base. I can.
Okay, now everybody has it. Yeah? You're all good? Yeah. Okay, made it to the last one. Okay, I think what I'm going to do is I'm going to do this in a separate piece of paper, because otherwise it's going to be really ridiculous to put everything there. Okay, so that's worked out? Yeah. Good. So I just want to make sure I copy the right thing. So 5 times 3 to the exponent x plus 2. 2 to the 2x plus 1. Okay, excellent. So what can we do? We can apply the log of 5 times 3 x plus 2 equals to log 2 2x plus 1.
Base 10.
Yeah. Now, what I'm gonna do here, because I have two different bases in here. I have a log, like I have a base of 3 and I have a base of 2. So instead of saying I'm gonna work or operate under like base 3 or base 2, then I'm gonna have like different ways of doing a lot of change of bases later on. So here, I'm just gonna take the log and it's just gonna be base 10. Okay, so we'll see what happens there. We gotta expand this thing, so that becomes x plus 2 times log of here. Wait a second, before I do that, where's my eraser? Before I do that, okay, I have to unravel this, because if I put this x plus 2 at the very beginning, it seems like this exponent applies to everything there, right? So what we're gonna do is we're gonna split them up into this form. So it becomes log of 5 plus log of 3 to the exponent x plus 2. Is that okay? Does that make sense to everybody? Right? Because if we do that right away, it looks like it's 5 times 3 is the base for this x plus 2 exponent, which is not. So from here, what we're going to do is now take this and multiply it at the front of log of 3. So that becomes log of 5 plus x plus 2 times log of 3 equals to 2x plus 1 log of 2. Okay. Now, this is the one, they're all different bases in here, right? Like, or base 10 now, but that's log of 2, this is log of 3, this is now log of 5. We can multiply it in. Log of 5 plus x log of 3 plus 2 log 3 equals 2. Is everybody okay? Now, what do you think we should do from here on? Yeah, like put the one with the x's on one side, all of just numbers on the other side, so let's just do that. Okay, what do you think our next step is going to be? No, not yet. We're gonna factor out the x's. So factor out the x's. We'll divide later. And then from here, that's when we can divide. Okay. So if we want, we can type this in the way we see it right now and get an answer. Another possibility is to combine these two. Okay. So, yeah. Go ahead and figure that out. And
Something like that we will have a calculator for, right?
oh yeah. Three, 9. Okay, I got 10.8227. Huh? 23. Yeah. Okay, yeah. 10.823 if it's 3 decimal places. Okay, I'm trying something different. Okay, well, different in a way that if you're over here and you type that in, you're gonna get 10.823. Yes. Okay. But what I'm gonna do is actually, instead of typing all of that stuff, okay, I'm gonna apply the laws of logarithm in here. So how can I do this? So log of 2 minus log of 5 minus 2 log 3. So I can go 2. Now this is subtracting log of 5. So that's the same thing as dividing 5. And then this is going to be minus 2 log 3. So that's the same thing as dividing by 3 squared, which is 9, right? Divided by log of, now this is being divided, right? Because its exponents are being subtracted, so the power must be divided. That becomes 3 over 2 squared. So if you want something a little bit simpler to type, that becomes log of 2 over 45 divided by log of 3/4. Okay, now go ahead and type this up and see if we're going to get the same answer. 10.823. Yeah, it's the same, right? So, yeah, you can go, type this in. You're gonna get the same answer. If you want to simplify it further, and then you get this one. Yeah, good. Can I divide these two? No, it's a tricky question. I gotta ask that question to you, but the answer should be no, right? Okay, so that concludes that last bit there. Certainly
Can Jordan see that?
many possibilities of working it out. Okay? There are some questions from the book that you can try. We have a little bit of time. I want to remind you that remember that hand-in assignment that I gave you yesterday? I think everybody got it by now, right? So, oh no, not this one. The other one that I gave you yesterday, that one is due on Monday. Plus you have something like this in here. Should I give you the exponential logarithm function review now?
Yes, please. And can we have the exams now or no?
Oh, do you want to do the exam? Okay, just everybody want to do the exam?
So I can start breaking it apart.
No, like the booklets.
I might not like start doing it, but at least I can start like